So thanks for the invitation. Good morning, everybody. As Taylor said, I'm the Climate Science Extension Specialist for U of A Cooperative Extension. And when pulling this presentation together, I was first sort of approached to talk about drought conditions, but I thought I would take a step back and think a little bit more about what some weather and climate tracking information might be useful for agriculture in general, and especially for urban agriculture. So this talk today is going to be not an exhaustive look at many different tools, but maybe just a quick survey of a couple of key things I think are good entry points for climate and weather information resources for working here in the desert Southwest and in Arizona in particular. And then I decided I would add on a little section at the end here too to talk about do-it-yourself weather monitoring too, because I think that you're going to find a lot of these resources is really useful, but you might have specific applications and information needs that really can be solved by setting up your own weather station at your particular operation, your location. So we'll talk a little bit about setting up those weather stations and then even sharing that information. So tracking weather and climate. So I was stepping back again and thinking about those key variables, and this will kind of set us up to think about where to find some of those resources and then actually how to monitor some of this information for yourself. So clearly there's some of the obvious ones like temperature. What might you look for in temperature information? From an agricultural application standpoint, you're going to look at things like freezing events. This is both an understanding of forecast for a freezing event, but then actually monitoring and looking to see if a freezing event has actually occurred. On the sort of growing side, you're going to look for heat waves and heat stress, monitoring and metrics, and then things like for crop development, growing degree days, so that accumulation of these heat units over time. From the precipitation standpoint, dry spells and irrigation. So having these long dry spells will give us some sense. You can think of them climatologically. When might they occur during the year? How long has the last dry spell been? And even from a forecast perspective, that might actually help you plan out certain activities that are coming up in coming weeks. And then thinking about heavy precipitation events and soil moisture status, the effectiveness of precipitation over a season, getting a total amount of precipitation, but then sort of parsing out when did that precipitation fall and did it effectively recharge soil moisture? So actually understanding that information both historically and then looking at forecast information. So the temperature and precip are kind of those key variables you'll find on most sites and in most forecasts. Then wind actually becomes really important in thinking about dust mitigation, pesticide application, and then calculation and monitoring of potential evapotranspiration, which we'll take a couple slides to talk about. And then relative humidity, thinking about leaf wetness and pests. If you're getting dew and hard, and even in frost situations where you could get a hard frost, knowing what that relative humidity and dew point levels are. And it also feeds into our calculation of potential evapotranspiration. Okay, so sort of my key starting point for any kind of weather information, and I know there are thousands of websites now that you can find both historical and forecast information, and then weather apps on your phone too that have things like AccuWeather, weatherchannel.com, weather.com are all private forecasts, and you can even hire now agriculture. You have been able to for a long time, but you can get private forecasting information from private forecasters. But I think that still the official sort of basic resource is really weather.gov, and so that's the official National Weather Service entry page. And the Weather Service is organized around local forecast office that have regions across the entire US. And so what that gains us collectively, nationally, is that we have local forecasters or inner regions that are paying attention and adjusting and making forecasts specifically for places that they live in as well. So some of these national forecasts don't have that expertise to be able to point to it. And most of the information that you see come out on these other websites is actually derivative from the National Weather Service. So I say, cut out the middleman and go to the National Weather Service website. It can be really tricky to find the information that you need sometimes. So here's a quick little shortcut to some buried gems in the page here. And I have been working with the Weather Service and trying to work with them to see if we can get some of this information, especially for agricultural applications, a little bit more refined. But here's a really nice tool. This is out of the Western Region headquarters. So that link right there will get you directly to this. This is actually a little bit hard to find if you're going in through that front page, but kind of hold on to this particular link here and it'll help you out. But this allows you to basically get forecast information for your point. And so the Weather Service forecasts now on a national forecasting grid that's about 4 kilometers. And so that'll give you at least a pretty localized forecast. And so if you do this, you can choose how many days out in the future and the forecast interval you want up in that access box right there. Click on this, and it's going to open up an interface on the right here. It allows you to turn some variables on and off up at the top there, and even add in, there's fire weather and aviation weather as well, but the basics I think will really work. And it'll give you things like the forecast for your location out through time, and you continue to forward it out in days. So if you can go up to 7 days on this particular forecast, but it'll give you an hour by hour take on whether or not you're expecting a freezing event, what the high temperature will be on those first 2 panes. Then some really handy things like wind direction and speed and how that varies throughout the day, and then relative humidity. So some of those key variables that we were talking about before. Then as you get down there, it'll give you the precipitation probabilities in those columns below there. And you can see here, this is a forecast period where we're not expecting any precipitation. So I think a really nice kind of entry point here for some of those weather service forecast products. And I've got a couple of projects, one in Southeast Arizona where we have a listserv that connects growers with the weather service. And we're starting one in Northern Arizona. We're going to try to round that out in Central Arizona as well. So if you're interested in getting on that listserv, you get some push briefings that come from the weather service of talking about upcoming weather events that may be high impact and things to plan around. So let me know if you're interested in any of those listservs. Okay, and then so another type of variable that's a little bit trickier to find, and you can see even on that previous weather service page, potential evapotranspiration, which is derived from some of these other variables, is not readily available. But we've got a couple of places that we can look beyond the weather service to find this information. So what is evapotranspiration first? And you may have encountered this in some other talks or some other materials, but evapotranspiration is that collective additive transpiration and evaporation. So it's the flux of water out of the soil and vegetation together. And we are interested in this, especially in the desert Southwest, because it helps us understand water needs within agricultural applications and irrigation needs. So evapotranspiration, when we think of it in terms, we can measure it directly, not very easily. We have to do this with instrumentation like flux towers. But climatologically and using weather data, we can think of this as far as potential evapotranspiration. So if we know temperature, wind, relative humidity, and solar radiation, these 3 variables together, if we know this on a very fine scale at a weather station in particular, and we know this over fine timescales, like say on an hourly basis, we can then basically estimate what the potential evapotranspiration is from a location, right? And so if temperatures are high, if wind is high, if relative humidity is low, which is going to be the interaction between having temperature and dew points far from each other, that means dry conditions, so those will be low relative humidity. And if we have a lot of solar radiation, all of those combined effects will give us lots of potential evapotranspiration. So there's the ability for the atmosphere to basically draw lots of that water, if available, from the surface. So potential doesn't mean actual. Potential just means it's there. If the water is available, it will try to meet that potential. So there's a little climatological graph here on the right that I had from some data from Miami near Globe. This is looking long-term. And this is an estimation of daily potential evapotranspiration, which is that kind of brownish color in the background there with daily average precipitation on top. So you can see here at this particular station, the climatological precipitation is highest in the winter. That's kind of our winter wet season, falls to dry conditions in April, May, and June, and then rises with the monsoon in the summertime, falls back in the fall, and then rises again towards the wintertime in December again. So that's kind of that seasonal transitional climate, those 2 wet seasons. But you can see there in the background, potential evapotranspiration is really a function of temperature and wind and relative humidity and solar radiation. This particular estimation is only using long-term average temperature on a daily basis. But you can see is that it follows in concert with the temperature track across the annual seasonal basis here in Arizona. And it peaks right around June 21st. And we have that longest, hottest days of the year with the high sun angle. And so we can take that and think of that in terms of a depth of water, a potential evapotranspiration each day, and add it cumulatively, which is that bottom graph. So that bottom graph right there, the potential evapotranspiration for this site Annual average potential evapotranspiration is about 59 inches of water of depth, and the annual precip is about 19 inches, right? So climatologically, this is an arid site, but we have resources where we can track this on a daily basis. And one of our key resources here in Arizona is the Arizona Meteorological Network, set up by Dr. Paul Brown, who's retired recently, and Dr. Jeremy Weiss has taken over running the ASMET site. And so it's got that simple address down at the bottom, but those green dots there are going to be active stations that have all of those key variables, including solar radiation, to calculate a very, very accurate potential evapotranspiration estimate at these locations. So if you can find one nearby, it can be, I think, a really useful tool to try to understand what crop and irrigation needs are at a particular location. So there's a lot of different information in here, but you can click on each site. You can get something like a daily report here. So this is looking at, on a particular day, looking across all of the sites. The ET is so again, there's all of those variables for that particular location, that daily summary. ET is evapotranspiration in depth of inches. And so that's the water that is being drawn out, the depth of water that could be drawn out based on these meteorological conditions at that site. You have other options in this site to be able to drill down and look at one station and look back in time. And there's some of these stations have data back to the mid 80s. And so you can do a real nice climatological analysis, as well as having this near real-time data coming out every day and every hour. There's a nice hourly interface on the ASMET site as well. Okay, so evapotranspiration is, again, it's a really key variable across the West. Anything where you're thinking about irrigation. There have been some really interesting and new and exciting tools that have come out thinking about evaporative demand. And this is a little bit more on the regional scale, and you can see it's even a national map, but it's using those same variables again, but gridded data and looking at it sort of retrospectively. So this would be something like if you're thinking across the region, or even at a fairly small location, but you want to look at timescales, say the last week to the last couple of months, to say meteorologically, was it hotter and drier? And was there more evaporative demand than we should expect for this time of year? This is where the evaporative demand drought index comes in really handy. And we can think about it at different timescales, which I think is really important. So we can look at, say, like the past week, and were the meteorological conditions really pushing on a location to draw out more water? And so EDDI, this EDDI index, is going to be scaled to something around normal, which is going to be a white color. And then if it goes into the blues, that means that evaporative demand was less than would be expected for this time of year in this time period. And then if it's in the reds, it's more. So was it hotter and drier, and was it windier? Was the relative humidity lower? That would draw that out. So you can see this particular screen cap I grabbed from October 14th, which was last week, was showing some meteorological conditions in the short term, really pushing on New Mexico and Texas, with higher levels of evaporative demand. And then the blues were where it was cooler and maybe wetter up through the Intermountain West. And then that's just for a week time scale. But then we can think about that over a longer time scale. Say the last month, that's where you get more of this average climate conditions coming into play. The same thing said that much of Arizona over the past month, and if you think back, that was kind of mid-September through mid-October, when it did actually get a little bit wetter and cooler, there was less evaporative demand, and it was above average still in Texas. So I think, and there's lots of different timescales you can look at here. But I think a tool like this in hand with the ASMET data can be really useful in trying to understand evaporative demand in our region. Okay, so if we want to think about drought conditions and climatologically, I've got a couple of favorite tools, and I'll show you some of the things that I've developed as well. And so this might be, we've got that weather forecasting information from the Weather Service. That's going to give you sort of a short-term look forward. And there is some seasonal forecast there. So 1 to 2 weeks, 3 to 4 weeks, and then out several seasons in the Weather Service realm. But then we can also keep track of what's going on in the more recent past, say the last month, the last couple of months, and even the last several years. So that'll give us some context for, was last month wetter than average? Was it warmer than average? So on and so forth. And so this particular tool is from the West Wide Drought Tracker. And you can see here, this is, say, for example, you wanted to have some context for your location, whether or not, was the temperature warmer than average for the monsoon, and was it wetter than average? And it was both of those things. And it was really useful because it felt, since it was so wet this summer, that I thought, well, maybe we were average and even below average temperature wise, and we certainly weren't. The climate change signal was strong enough that even under these wet conditions, which you see on the right map, it was very wet, record wet in some locations, but still above average to even record warm in some parts of the state. So I think that having this kind of information is really useful. And the Westwide Drought Tracker site has lots of information across the region for temperature and precipitation and these different drought indices. And you can get current maps as well as archived maps. And then you can also get time series. So if you really wanted to understand this particular year in the context of, say, the last 120 years, you'd get a nice time series like you see down there in the lower right. Okay, and I've been playing around with some ways of trying to track local climate as well. And so I put some effort into trying to think about what are the stations across Arizona, New Mexico that have near real-time data. So they're reporting at least within the last week or so, if not within the last 24 hours, and also have a long-term historical record. So at least 30 years of data, if not, some of these stations have 100 years. And so the idea would be that, can we look at, as the daily weather unfolds, can we put it in a climatic context? And so these little red dots here are stations that are doing this near real-time reporting, but have nice long records. And the idea is can I summarize this data and look at different metrics that give us an understanding of how things are shaping up for, say, this last monsoon season, or the current water year, which would be October 1st through next September 30th, or the past water year, or the last calendar year. And the idea then would be, how many times did it rain? When were the freezing events? When were the heat waves? When were the record temperatures? What did the precipitation fall in the season? And what I came up with is it's a fairly complex plot, I know that, but the idea is that it's a one-stop summary of the climate at a particular station in that climatological context that hopefully would be useful for a report. Like if you needed to do a seasonal report, or you just needed to look back on, say, the last water year and say, well, when did it rain in the last 12 months? And was it a lot or little? And so this is like that one-stop shop that's for this particular station. So it gives you a lot of information, some key information on the location and how long the period of record is. This little bar chart at the top gives you a sense of what the timing of precipitation was. Was it late or early in the year? When was the first event? When was the last? Some simple metrics of total precip. How many times did it rain? What was the average rate of precip on a daily basis? The number of heavy, light, moderate, heavy events, and then some metrics on temperature. There's some little key things in here too. The little orange diamonds show us if it was a record wet for that particular day. And then the blue and the red diamonds at the bottom tell us if there were records. So it's a place to go back and say, okay, there was a heat wave here, there was a freezing event here, the heaviest rain was here. And so we've got this for over 108 stations. And some of we have ones for every year in the particular record. So there's about 5,000 of these different charts on this site. And they update every day. And so we can use them to monitor climate going forward as well. Okay, so there's, again, that was like 4 or 5 sites. There are probably 10,000 weather and climate sites out there. My job is to help you find the information you need. So this is, again, just a kind of a quick introduction. And I'm always encourage you to reach out to me if there's something I can help you find. But one of the strategies is collect your own data. And these weather monitoring networks are typically pretty dense in urban areas, and not everywhere though, and not even in certain parts of town necessarily. So putting up your own weather station can be a pretty approachable thing. And this wasn't even probably the case 10 or 15 years ago. Weather stations have become increasingly more sophisticated, cheaper in price, and much better quality. So you can actually do some pretty good monitoring. And so collecting and sharing the data can help improve with your decisions and planning, because it can give you a sense of things that, say, the local weather service forecast can't really put their finger on. And you may be working or operating in a low-lying area that has cool air drainage that these graded forecasts and the monitoring products won't actually pick up on. So you may be in a cool spot and you may be hitting freezing events much, much more often than anywhere around. And so having your own data is going to give you a way of actually calibrating some of this other information you're seeing from, say, a weather service forecast, because on average, I'm about 5 degrees cooler than that. You wouldn't know that unless you had your own data. Okay, so personal weather stations, again, you don't need a $10,000 weather station. You can if you got it and you want, but you can really get pretty good weather stations for a couple $100s, $250. Some of the higher end ones are $500, and some are down to $100. And then you've got to kind of look at the trade-offs there as far as quality. But siting is still the single most critical issue of putting the station in a good spot and making sure it's capturing what you want to capture of the particular location. The wireless aspect has made siting stations much, much easier, and they're now very common and cost effective. And there's lots of different options for logging, managing, and sharing data. And this improves every year over time. So basic weather station variables, what we talked about earlier, air temperature. You also get barometric pressure, often relative humidity, wind speed, and direction. Precip, some have solar radiation, so you can actually even do Penman-Monteith kind of evapotranspiration like ASMET does. That's on the higher end, more expensive stations. And some actually have soil moisture and leaf wetness. They can be of varying quality, but I think they actually are getting better and can be really helpful to have that information as well. So, and this is an old screen capture of some different kinds of stations. There's a couple of Davis station sites out here, ambient weather, net atmo. And again, these are kind of a wide variety of price ranges. Generally, these stations I'm showing here are anywhere from about $200 to $1,000. But again, coming down in price every year. Okay, so ideal weather station siting requirements, temperature and humidity. There's a lot here. Just quickly kind of talk about it. Should be placed on patch of level ground over a surface representative of the area. You don't want to put it over a parking lot, for instance, if you're not interested in parking lot temperatures. So you're going to want to have kind of a natural or irrigated area. Should be mounted in a ventilated radiation shield. That is kind of optional. Ventilated means you're actually blowing air through the shield. Those are on some of the more expensive stations. Most stations don't have that, so I wouldn't be too stressed out about not having that. You want to height it about 4 to 6 feet above the ground, so it's kind of chest height. And then place the sensors at a horizontal distance of 2 times the height of the nearest objects. You want to kind of keep it away from buildings, away from trees. You want it to be exposed so it's able to sample that environment. So this really applies to all of those variables we're looking at here. And then wind's trickier. Ideally, this is crazy though, ideally mounted at 32 feet. So that is the standard measurement level. And we don't even have that largely with airport measurements. And so you're going to really try to optimize this as best. The higher you do, it's going to give you more accurate. But even my home weather station is sort of near it's near my roof because I can't get it that high. So I do it as best as I can. And so when placed on the side of a mast, the sensor should be placed on a horizontal boom extending outwards from the mast so that the mast itself doesn't interfere with the measurement of the wind. And then for precip, it can really be at the sort of the same height as the temperature measurement. And if it's an all-in-one package with wind, you just kind of do your best. If you want to put that on the ground, kind of at chest height level, and they're all together, that's good. It's going to impact your wind, which will be a little less favorable. If you move your instrument package up, it's going to impact your temperature, but improve your wind. So you have some trade-offs there. And again, it's just really an optimization to make sure you're getting the information that you want for your application. So there's some really that's that 32 meter height, which is not practical for very many people. And here's sort of a lower ground level installation here. Side of your house, if that's good, and if you can separate the temperature from the wind, that's fine. But these integrated packages, like in the lower left here, in the lower right, putting on a mast is fine, as long as you can kind of try to get them out in the open and away from obstructions. Okay, so just sort of weather station considerations. If it looks and feels cheap, it probably is. And you can probably get really good measurements from sort of these cheap feeling stations, but they just won't last very long. And I've had stations I've had out for almost 10 years that are just made out of plastic, and they've done really well, but they were like about $200 to $300 price point. I think on the $100, they probably would only last a couple of years. Again, optimize the station type and setting to capture the most important variables to you. Conduct a field study with data loggers. So if you have, and this is a little bit on the high end application, but if you have the ability to, put the weather station or some data loggers, you can kind of move it around for a while to make sure it's getting the kinds of information you want. And stations still need to be maintained and replaced over time. Even these, you can look for some of these stations actually have replaceable sensors in park. So that actually helps you maintain the station rather than just sort of throwing a station away and putting up a new one. Okay, getting a station online. This is really varied over time and continues to change. Many of the stations have add-on packages that you plug in and get directly on the internet. Some of them now have Wi-Fi compatibility, so they just get right on your internet and go to these third-party services. And so that is an option. But there are, I would look around too to make sure that you can share your data even outside of that particular service that it provides. So like Weather Underground between Davis stations Davis stations allow you to share to Weather Underground, but also to something called the Citizens Weather Observer Program, which is kind of a crowdsourced way of collecting and sharing data back out. And it allows you to do really cool things. Like this lower right is Weather Underground. So you get really nice visualizations of your data. And the upper left here is something called MesoWest. So if you share it, you can go to both Weather Underground, but also this MesoWest, which does really nice plotting and tracking of your data and shares it out to other people. And sharing it out to other people means that the Weather Service actually uses this home weather station data to help improve their forecast information. So we've been trying to work on seeing if we can improve, say, frost and freeze forecasts by having better information come in from these highly localized spots. And I myself am using home weather station data now too for drought tracking. So I've got a product up here that's the Arizona Drought Tracker, where I'm pulling all of that station data and then comparing it to historical data, so we can look at real small scale changes in drought conditions across the state. So that's all I have for today. And I think I'm just about out of time, but I'm happy to field any questions I have time, and I can stay on and chat. And then also feel free to reach out and ask me any questions if you have any as well.